Welcome. So we're going to answer this question before us. It is part C, so make sure you watch part A and B first. Okay, one bowl is chosen at random. From it, two pieces of fruit are chosen at random without replacement. If both pieces of fruit are apples, find the probability that bowl A was chosen. Okay, this is where we need to be careful. And you need to really think about what the question is asking and what type of probability is in use here. The fact that it's told me that if both pieces of fruit are apples, so meaning, we've already done this and we know that both pieces are apples. I now want you to find the probability that bowl A was chosen. And hopefully by the way that I've phrased the question now, it's quite clear that we're dealing with conditional probability. So both pieces of fruit are apples. Find the probability bowl A was chosen. So it's the probability of A given will pulled out two apples. So you really have to make sure that you can read the question to kind of figure out what it's saying. Okay, so here we're then going just to write out in full what this means. We know, based on our formula for the conditional probability, that this is going to be A intersection of two apples over the probability, now the probability of two apples. Now we just need to find each of these. Think about our tree diagram. So we know the first thing that we're doing is we're choosing a bowl. So either bowl A or bowl B. That means there's a 50-50 chance of getting either one because there's two bowls and we're choosing them randomly, so 50-50. Now, we really only care about our apple line, so let's just write down the apple line here. For bowl A, we know that there are 3 apples out of a total of 8, and also remember we're doing this without replacement, so this next one will be 2 on 7. And then we continue on for bowl B. Now, for bowl B, there are 7 apples, so 7 out of 8, and then the next one will be 6 on 8. Oh, sorry, 6 on 7. My bad. 6 on 7. Now, this line here will give me the probability of A intersection of 2 apples. So by doing this, by going a half times 3 on 8 times 2 on 7, that will give me this, which is right there. So let's now do that. So we're going to go a half times 3 on 8 times 2 on 7. Now, don't be silly and try to multiply before simplifying, because look, that 2 cancels with that 2. And that's all we can simplify here. So that means now what I'm left with is 1 times 3 is 3. 8 sevens are 56. So that means up here I'm going to get 3 on 56 divided by, now the probability of 2 apples. Now the probability of 2 apples is, I'm also going to have to consider this, the probability of B intersection of 2 apples. So that will be, if we grab another highlighter, this line right there, that will give me that. So that will be a half times 7 on 8 times 6 on 7. Again, make sure that you simplify before multiplying. This will be 7 dies with 7, 2 becomes 1, that will become 3. And just like that, we end up with 3 on 8. See how easy that is? You just got to make sure that you simplify first. Now, for me to figure out the probability of 2 apples, I simply just add these together. I simply just go 3 on 56 plus 3 on 8. Now, in order to do that, I'm going to have to multiply this by 7 and this by 7, which means I'm going to get 3 on 56 plus 21 on 56, which is going to leave me with 24 on 56. So that means right here, I have 24 on 56. I would then write this as stay, change, flip. So if I come here, my first one stays, change it, flip it. As you can see, things cancel out rather nicely. That will cancel with that. That will become 1. That will become 8. My answer will be 1 on 8. And just like that, we're done. So the answer is 1 on 8 there. The back of the book might give it a 0.125. But that's it. That's how you answer that question. A very nice question. Make sure that you simplify before multiplying. Otherwise, you're going to be in a world of pain. But that's how you answer part C. Hopefully you found this helpful.